Hi everyone, welcome back to From Brute to Best. In this video, we're going to deeply understand one of the most important interview patterns, sliding window. If you've ever solved a problem using nested loops and felt this works but something feels off, then this video is for you. We'll start with brute force, understand why it's slow, then step by step move toward the optimal sliding window solution. And most importantly, we'll cover the mistakes that silently break solutions in interviews. I'm assuming you already know what arrays are and have basic coding experience. I'm also assuming you know what time complexity is at a high level. If you don't know sliding window, or even binary search or complexity, please let me know in the comments. I'll create a separate beginner-friendly video just for that. Let us consider this problem. We have an array of integers of size n equals 10. We have to find the maximum sum of a subarray of size k equals 3. Let's start with the most natural approach, brute force. We take every subarray of size k, in our example 3, calculate its sum and track the maximum. Let me quickly write some code for the solution with this brute force approach. To save some time, I have already created a class here. I will simply write the program to solve the problem. Quickly create a method to find max sum. The parameters of the method will be an integer array and the window size k. We will have a max sum value, and in the brute force approach we'll simply iterate through all the elements of the array. So I will start from 0 index while less than equals to array length I plus plus. Here I will have a sum variable initialized to 0 to calculate sum of each subarray. Now I will again separate or extract the subarray. So I will have another loop here, nested loop basically. And here I will simply add the elements value into sum. Correct? And at the end we will return the maximum. And after each subarray sum is calculated, we will simply compare whether the calculated sum is greater than our existing max sum or not, right? So we will use the max function of math package. Simply give. That's it. So this is the brute force way to solve the problem. Okay, now let me just give. So this is our array and our window size case value is 3 and our expectation is 20. So my expectation is if I execute this code, my maximum function should return 20 with this input and my test case should be passed, right? So let me simply execute this test case. So as you can see, result is 20 and status is pass, right? Now for your understanding, let me quickly add some sysout here just to show you how brute force is calculating each subarray and its sum, right? So let us quickly add some sysouts. So this will print subarray number, let's say I plus 1, right? And after that I will have a print. In this print I will simply do this. Inside nested for loop I will first have a condition, and otherwise I will simply print the element value in the console, correct? This is error of j, right? And after the nested for loop I will simply give another println, sorry, right? And let me quickly print the sum as well. Right, so this is outs whatever I have added, it's just for logging the messages so that you will understand the values after each iteration properly. Okay, so these are not mandatory for this program. Now let me quickly run the application. Okay, so here if I can, let me just make it big. Now you can see subarray 1 is the 4 to 7, the first three element of the array, and sum of this first subarray is 13. Similarly, subarray 2, subarray 3, subarray 4, subarray 5, and it has calculated sum for each and every subarray and then find what's the maximum sum of for this particular input data out of all the subarrays, right? While this approach works, the problem is how many times we repeat the same work. For each index, we are recomputing almost the same sum again and again. Let's have a look at our example with the array 4, 2, 7, 1, 5, 8, 3, 9, 3, 6. During the first iteration, we are calculating the sum of the subarray 4, 2, 7, and during the second iteration, we are calculating the sum of the subarray 2, 7, 1. Here, you can clearly observe that we are summing up the same elements 2 and 7 twice in 2 iterations. Similarly, during the third iteration, we are again summing up the common elements from the second iteration, 7 and 1. This seems unnecessary, right? The number of common elements increases as the size of k, the length of subarray increases. This leads to unnecessary nested loops and higher time complexity. And this is exactly where interviews start rejecting solutions. Now, let me tell you how the sliding window approach helps in reducing the time complexity and improving the performance. In the sliding window approach, we remove the nested loop and calculates the sum from the previous subarray sum. So, For the first subarray of k elements, we will calculate the sum as usual. For the next subarray, we will add the next k plus 1 element to the sum and subtracts the first element to get the sum. We will repeat this step until we reach to the last element of the array. Now here's the key observation. When we move the window by one step, we don't need to recompute the entire sum. We remove one element, add one element, and the window slides. Sliding window is not about code. It's about maintaining a moving range. We expand the window, update the state, shrink when the condition breaks, and track the answer. Most bugs happen during shrinking. Let's look at a very common wrong approach. Let me write the simplest code following the sliding window method. So let me clean this code first for your understanding. Okay, so let us have this empty method now. Okay, now I will write the simplest code of a sliding window algorithm. Okay, so let us have int sum equals to 0, and we will have a max sum calculation. Right now, the first for loop will look quite similar to what we had already written in the brute force approach, right? So I will explain it to you. Okay, sorry. Okay, I missed the operator here. Just and now here, instead of calculating the sum in the nested for loop, we will calculate the sum here only, right? Now how we will do that is we will add the element in the current sum. Next we will check if our index is greater than equals to sliding window size or the subarray size or not, right? If this condition satisfies, then we will simply subtract the first element from the sum, right? So first element means current position minus the k, right? Minus the size of the subarray. Okay, now after if, we will simply check whether we have a new max sum or not, right? And at the end I will return max. Okay, now this is the simplest way to write a sliding window code. Okay, now I will just explain it to you what's happening here. Here, instead of having nested for loops, we have removed one for loop and we are calculating the sum as we move the window to next element. Okay, so for the first kth element, okay, let us take this example of this array. Okay, this is our input array, correct? So let me just keep it here. So on first iteration it will come I is 0, so sum is initialized with 0. It will add first element, that is 4, to sum. Next it will check whether i's value greater than k or not. Now k's value here is 3, right? So it's not greater than equals to, so it will skip this if part. It will again check max sum 4 and it will see that sum is max now because max sum is 0 and sum is 4, so it will add the max sum here. Then again goes to next iteration. On next iteration sum will be 4 plus 2, that is 6. This condition will again not satisfy So again it will update the max sum and continues. On third iteration it will add some value 7 to sum. So now sum will become 10, and here this condition will be satisfied because i's value now is, sorry, it will again not satisfy because I is 3, 2 here, and k is 3, right? So it will again come here, it will update the maximum value, or let me write it down everywhere, right? So for first iteration sum is 4, this condition is false, right? And here maximum is again 4, right? On second iteration sum is 6, this condition is still false and maximum is 6. On third iteration this is 13, this is still false and maximum is 13. On next iteration when it comes, now sum will become 14, right? But this condition will satisfy now, so true. So what it will do, it will basically subtract the first element from the sum. So i's value is 3, 3 minus 3, 0. So first element it will subtract. So now the sum will become 10. And on the max sum, so since the existing max sum is 13, so it will keep 13. It will not update, right? Similarly, when it comes to next iteration, again, so now sum value is 10, right? So next iteration, so element 5, so it will become 10 plus 5, 15. This will again satisfy this condition, so it will return true. And now here sum, again I will remove the first element of that window. Okay, it's not the first element of the array but for that window, right? So i's value is 4, 4 minus 3, 1. So this element it will remove, right? So it will 15 minus 3, 2, that is 13. Again here it's not greater than the existing sum, so it will not update, and so on. So as you can clearly observe, with this approach we have been able to successfully remove or reduce our complexity from order of n into k to order of n, right? So now let me quickly remove this uncommented codes here. This code looks logical. If we run our test, it will return the correct max sum, that is 20, and our test execution will pass. Let me run our test case. We are passing this as our test input, array as 4, 2, 7, 1, 5, 8, 3, 9, 3, 6, and k equals 3. As you see, our test execution has passed. So far, everything looks good, but it will break for some edge cases. Let's consider an edge case where all the elements in the array are negative numbers. For example, let's say our array contains -5, -2, -3, and -1, and k equals 2. So we need to find the maximum sum for all subarrays of length 2. We expect our program to return -4 as the max sum, but if we execute our program, it will return 0. Let me update the test data, window size, and expected result. Now let's rerun the program. As you can see, the result for the test case number 2 is 0 instead of -4. Now let me show you what exactly is wrong with our existing code. Since we have only negative numbers in our array, the sum of any subarray will always be negative, but we have initialized max sum with 0, so the sum of any of the subarrays will never be greater than the max sum. At the end of our program, it returns 0 as a result, and our test case fails. That the solution to this edge case failure is very easy. We just have to initialize max sum with constant integer dot min value instead of 0. This will make the max sum value comparison correct even if the subarray sum is negative. We have already updated our code. Let me rerun the program. As you see now, our program ran successfully and all the test cases passed the execution. But our code is not fully correct yet. Let me give you another example of input. In this case, we will give the value of k, size of subarrays, greater than the array's length.
So as I was saying, so our array length, so let's say n is equals to 2, but our subarray length or window size we have defined is greater than the array size, that let's say 3. Now let me give you the example itself. So for example, this test case, let me move everything out from here and paste here, right, and uncomment this specific test case. Here also expectation is 2, so let me move everything here, right, commented it, and similarly this test case, or let me move this here. You just have to comment everything, right? Now here, as you can see, our array length is 2. That means it contains only 2 elements, but the window size or subarray size we are defining is 3. Now our expectation is, since it's an invalid input, what it should do, it should not return me a valid data, or it should only return the initialized max sum value, whatever we have initialized, because it should not be able to calculate max sum of the subarray since it's an invalid input, right? So that's why we are expecting the initial value what we have initialized max sum from our code, right? But if we run this code, okay, so let me quickly run it. Here, as you can see, it's returning 3 instead of the initialized value of max sum. It's returning 3. Now why it's behaving like this?
The window is updated, but the result is calculated before the window becomes valid. This fails silently for edge cases. This is the correct way to do it. We control the window size explicitly, shrink at the right time, and update the result only when the window is valid. This version works for all valid inputs. Let me update the code. Please be with me while I complete the code changes.
So to fix this issue, we have to make some change in our existing code. So basically we just have to validate our window size before updating the max sum value. Okay, now in order to do that, we have to add few variables here. Okay, now here it's fine. We just have to add a range variable for window, that will be left and right. So left and right will nothing but the range of the window. So what's the current position of the window? Left is the beginning position and right will be the ending position. So here I will replace this I with right, and I will update this condition with this thing now, right. Okay, here we will have this summation as it is. Instead of I, we will use right here. Next, this condition, this window shrinking condition, we have to modify. Now here, instead of I greater than 0, we will write something like this. Right minus left plus 1 equals to k. Okay, don't worry, I will explain what this condition is and how it's solving our problem. Okay, and here we will move this code inside if block, because now we will only update our maxsum if the window size is valid, right? And then we will have this sum. Here we will, instead of I minus k, now we already have left position, so that we will use here, and after that we will increase the left value. Okay, and return, it will remain as it is. Okay, now the code change is done, right?
Explain the change I have made. Instead of iterating through all the elements and updating the result even before validating the window, now I am using left and right range for the window, and I am validating the window before updating the max sum. So the max sum will only get updated for a valid window. Here I have initialized left to 0. I am starting the loop with the right as 0. Inside the loop, I am adding the current element to the sum. This sum will be the sum of the subarray. Next, we are validating the window. This condition, right minus left plus 1 equals k, will always validate the window size correctly. Let me explain this logic in some detail so that you will not have any doubt. Let me take the example of the same input for which our old code was failing. So the array contains 1 and 2, and the value of k is 3. During the first iteration, left equals 0, right equals 0, sum equals 1, and the equation right minus left plus 1 is produced 1. This is not equal to the value of k, that is 3. So the loop will move ahead without updating the result. During the second iteration, left is still 0, right is 1, sum equals 3, and the if condition produced as 2. This is again not equal to k, and the loop will again continue without any update to the result. We have already reached the end of the array, and the loop will break now. This will produce the result as we expect. Now let me add a few more input data to test and run the program. As you can see, all of our test cases pass the execution. Let's talk about all the edge cases. All negative numbers, window size equals array size, k equals 1, or invalid input. Most wrong solutions break here. One important clarification. Sliding window is for continuous subarrays. 2 pointers are for pairs or positions. Mixing these patterns is a common interview mistake. Before writing code, ask yourself, is the data continuous? Is brute force using nested loops? Am I tracking a range? If yes, think sliding window. Sliding window is not something you memorize. It's something you recognize. If this video helped you, check out the shorts linked in the description. They cover common mistakes in under 60 seconds. If this video helped you, please take a moment to like it. It really helps the channel grow. If you know someone who's preparing for coding interviews, feel free to share this video with them. If you have any doubts, or if there's any topic or algorithm you want me to break down next, leave a comment below. And if you want to keep learning by moving from brute force to interview-ready thinking, consider subscribing to the channel. I'll see you in the next one.